with respect to convolution, we can write that in convolution we used to perform folding shifting of signals initially. Okay, so now we have to fold a signal and shift a signal, and then we have to multiply and add it with the another one. So that means for a circular convolution, we can write the output of circular convolution, we can write it as summation of x1n and x2n. Okay. Now two sequences x1n and x2n both are periodic. Okay. Both are periodic. So suppose we have to then this is the signal, it is kept as it is. So x2 signal must be folded and shifted. So as it is a periodic sequence, the shifting will not be just like in a linear sequence. So this will be called as using modulo. That means if I want to shift it by k unit, I will call it x of n minus k. In the bracket there comes a n, another n. It will be called at x of n minus k modulo n. That means you are actually going for a circular sequence shifting. That means you are going to shift a periodic signal. So here actually the property of circular symmetry of sequence will work, and it is having its importance. So just explain it. Suppose I am having a simple sequence of like this. I am having a simple sequence like this. This is n, and it is 1, then 2, then 3, and then 4, and these are at 0, 1, 2, and 3. This is a sequence. Now we know how to shift a sequence. Suppose if I want to shift the x of n minus, suppose I want to shift, this is x of n. I want to make it x of n minus 2. So what is going to happen? 2 point, this will going to start after 2 points from 0. That means the sequence will be like this. This will be 0 and 1 will be 0, 0, and it is 1, 2, 3, and 4. So the whole sequence has been shifted to 2, 3, 4, 5. Okay. So this is basically when it is a periodic sequence. If we shift it, it will be like this. Now, if the sequence is periodic, then what is going to happen? Just check it out. Now my sequence is becoming periodic. That means this sequence, if I extend this sequence, it will be again 1, 2, then 3 and 4. After 3, we are getting 4 here, 5, 6, 7. Again 1, 2, 3, 4, 7, 8, 9, 10, 11. Even before here also, we are getting 4, 3, 2, 1. So it is minus 1, minus 2, minus 3, minus 4. So this is a periodic sequence of xn now. Now if I want to shift it, this periodic sequence xp n minus 2, what I am getting? I am getting that this 0 point is going to shift I am concerned, I am going to shift it and I am going to take only the 4 sequences. Okay. So what is going to happen? Everything will shift. Everything will shift in a sequence. So this value of this was 1, so this is 4, this is 3, this is 2, this is 1. This value is come to here, 4 is coming to at 1, and 1 and 2 is coming to at the sequence of 2 and 3. That means if I draw, I am getting that this, change the color, okay, as it is periodic sequence, these 3 is going to come after 2 points, that is it is going to come at 0th sequence. So the 3 is coming here, the 4 is coming at 2, the 4 is coming here, and these 2 are actually shifted by 2. So 1 is coming at, so it is 0, this is 1, 1 is coming at 2, and 2 is coming at 3. So this will be the shifting of x of n, minus 2, modulo n. That means we can write this shifting, it is actually following a circular path. So we can able to express much easier way in the form of a circle. How we can express that? Just let's see. So 3, 4, 1, 2 was our sequence. 3, 4, 1, 2. So if I just put these sequences in a circular fashion, suppose I am drawing a circle here. I am drawing a circle here. Okay. This is my x of n. Now for what I have 4 sequences. First I am plotting the sequence in a anti-clockwise manner. I am plotting it circularly in an anti-clockwise manner. So what was our sequence? So it will be, first I have to put x0, then in an anti-clockwise manner I have to put the x1, then I have to put the x2, then x3. So what was our sequence? It was 1, 2, 3, 4. So this is 1, this will be 2, this will be 3, and this will be 4. Okay. Now what we have to do? We have to shift it. We have to shift it by 2 points. 2 points, that means what we are going to do? We are going to shift every sample circularly in anti-clockwise direction by 2. Okay. So I want to shift, so that is basically I am performing modulo 2 operation. That means I am performing x of n minus 2. This x of n minus 2 I want to perform. So how I want to perform this? I am taking another circle and I am going to shift each and every sample by 2 units in anti-clockwise fashion. So what is going to happen now? So 1 is come here. Okay. So 1 will come here. Here will be 1. 2 will come here. Then 3 will come here. 1 will come here. 2 will come here. 3 will come here and 4 will come here. So if you take that, this is the x0 dashed, this is x1 dashed, this is x2 dashed, and this will be your x3 dashed. That means now it is x of n minus 2. So what was the sequence we have got in our linear when we just shifting the linear sequence? It was 3, 4, 1, 2. Here also you will find we are getting the sequence x0 as 3, 1 as 4, then 1 and 2. So this is the utility of the circular symmetry when we are going to shift. Basically, utility of it is when we are going to shift a periodic sequence, we instead of the linear one, we can use it in by shifting the values in the delay should be shifting the values in a anti-clockwise direction across a circle. Okay, and that is basically circular symmetry. We are going to get the same result if we shift the signal linearly. If we shift the periodic signal linearly. Okay, thank you.